Good morning, guys. Okay, so let's get started for today's lecture. I think most of you have your laptop with you. If not, it's alright, you can write down the SQL commands that we learned today on the slide. Okay. So before we get started, I just have a couple of things that I want to talk about. The first thing is that I'm thinking about for midterm 2, we might test on really going to the computer lab and answer questions by working on SQL. Okay, so I'm thinking about making the midterm 2 part, and one part is going to the computer classroom and do it really on the machine. And the second part will be the same for written part. But then, good thing is, for written part, then we'll have less problems. Okay, and then the testing time will be also shorter. So that's just part of my plan right now. I just want to let you guys know. If in the middle of learning it, you think that would be a terrible idea, let me know. Okay, I just think it's better to test it that way instead of testing you on the paper, writing code. The second thing is, I'm going to talk a little bit more about other stuff. So if you haven't done so last time in terms of creating the tables on your MySQL shell, you can do it right now. So also connect to your SQL shell server, either to the CSV one or your local one. Another thing is, so I originally planned to spend around 3 lectures on SQL, but now I think we might spend a little bit more. And also for NoSQL, I plan to start it next week. So I will still start next week, maybe next Wednesday or Friday, and then we will spend also a bit more on NoSQL because I think there's a lot of really good stuff you can learn from it. But then for other chapters, there might be a trade-off. We will be learning about some applications, but those will be mostly taught through instead of getting really hands-on, so I might reduce the lectures on those. Other than that, okay, so before we finish the lecture, remember to remind me, I'll ask you guys for the flavor of pizza tomorrow. Okay, so we'll decide that before we finish the class. And before we finish, I'll also ask around whether any team wants to go first tomorrow for the presentation, if you have other obligation on, or if you have to go later after a certain time. Okay, I'll ask you guys that later. Alright, so let's talk about what we will learn today. Last time we learned about some really basic SQL commands for querying information. And today we will get into a bit further in terms of talking about the set manipulation. So if you study the textbook, you'll see it talks about we have union, intersect, and except. However, for the MySQL we use, if you really try to test it out, even though these really help you to think the concepts is really easy to understand, these two are not supported in our MySQL. Okay, so later on I'll show you what are the alternatives that you can implement. Not using these, but using other stuff that we learned. Okay, so union is supported in terms of the set manipulation, but for these two, they're not. And we'll also talk about the other set operations. The first one is in. I'll show you how it works later. Basically, it's like testing an element, whether it's in a given set. And also, 2 really interesting operations. One is you can put any operator that compare the value, and then you say any, or compare to all of them. So this is similar to the idea of compared to some in the set, and this is compared to every in the set. I'll show you how it works later. And then we will also use exists, which you can use to check if the set is empty. So let's take a look at the first query. So if you're working on your laptop today, I think it might be a bit easier if you open a notepad. So we type on it, and then, because I'll keep going back and forth between the lines, and you can, after you finish, copy and paste that to the shell. That's just a lot easier. All right. So let's look at this query. So we want to find the names of sellers who have reserved a red or a green vote. I'm sure you guys are pretty familiar with the schema now. Okay? The sailors, reserves, and votes. So let's work on this one. What do you think? What are the tables that will be involved in this one? you want to find the names of sellers who have reserved a red or a green book. Let's type down the template first. And start with the from clause. Out of the 3 tables, sailors, reserves, and boats, which are the ones you think are required for this one? Anyone?
All of them?
All of them, right? All of them because, first of all, we want the name of the sellers, and that only comes in the sellers table if you remember. Also, we want to know who reserves the boats that are red or green, so reserved has to come from the reserves table. Then we move on and take a look. It's specifying the colors of the boats, right? Either red or green, and that only comes in the boat table. Okay? So if you recall from last time, we can ignore the range variable, and that will still work, but these are giving the variable name for the table we're using. So when you're referring to the fields that you want to compare or to select, it's just a lot easier. Okay. And what are we trying to select? Here say find the names of sellers, so we are selecting the names of the sellers, right? So you select S name because S name is in the sellers and is from the S table. Before we move on to the where clause to think about how we would join the tables together and what are the criteria we're specifying, just a few things to know. Right here we're using select, but when you really map this idea to relational algebra we learned before, this is actually the same for the projection, correct? Because we're selecting the fields that we want. However, when you look at the where later, that we will put the criteria and the conditions to say which are the tuples, which are the rows we want, this where is like the selection in relational algebra. So just don't get confused between the selection in relational algebra and the select in SQL. Okay? Sometimes it can get a bit confusing. Also right here, we are selecting the S name from sailors table. So if you remember from last time, if the answer actually have duplicate results, duplicate tuples, in my SQL, it will actually return the duplicate, so you might see the same name repeating different times. Remember what's the keyword that we can use to eliminate the duplicate? We can use distinct. Okay? So we'll be using the distinct quite a lot today, just so that the answers are clearer, instead of seeing a lot of repeating tuples. Alright, so after all these, let's go back and rethink about our query. So our goal is to find the names of sellers who have reserved a red or a green boat. So now we have decided what's the field we want and what are the tables that will be involved. What should we put in the where clause? There are quite a lot of terms we should put in this time. Let's start from thinking about how we join the tables together. And by doing what can we associate sailors and reserves table? If you think of it in relational algebra, it's basically taking a natural join between sellers and reserves, correct? In a natural join, it is it's comparing the field with the same name, that whether they have the same values. So here we can do the same, which is basically saying, okay, now I want to make sure sailors are associating with the reserves, then you just do s.sid equal to r. So what this is saying is, by making sure the SID from sailors table is equal to the SID from reserves table, I'm combining them together. So I only want the tuples when this is true. So if we do the same thing, to associate reserves and votes together, what do you think we should do? What's the common field between them? BID, right? So you can just do R, the BID equal to okay, so in MySQL, when we are doing comparison, we directly use equal sign. So this is not assigning, it's just doing compare whether it's equal. Anyone remember if it's comparing it's not equal? Yeah, so I'll just quickly change it here, but this is not what we want to do here. So it's less than or greater than. Okay, so that's for non-equal. Okay, but we're not doing this here. I'm just reminding you. If you want to do a not equal, it's less than or greater than. So it's not like nothing like this or anything like that. All right, so now we are sure the sales table and reserves table are associated. Also, the reserves tables and votes table are associated. What next? We want to check, because we want to find the sailors who have reserved a red or a green vote. So what should we do next? Red or green vote? Go to the next line to continue it.
B.color is red, so B.color is green.
Yeah. So because in the table that the template I gave you, I have data type for color being string, so just don't forget to put quotes. Okay. So here we use or because it's saying whether either reserved a red or a green vote. So here you want to be careful. Do you think we should put parentheses here? You think about the logic. It's required. Okay. Anyway, so that's what's going to happen. If we want to find the names of sellers who have reserved a red or a green vote. The part that you want to be careful of is just here we have a lot of terms in the where clause. Okay? The first two are for joining the tables. This is for sailors and reserves. This is for reserves and votes. And then this whole thing, just making sure you get the votes starting with the red or green. Okay? If you're ready, you can copy it, and we'll see what's going to happen from here. So we paste it, which is going to return the answer. Okay. Let's go back to this. If you take a look and recall when we were working on this query relation algebra, we were saying there's another way of writing it instead of just directly using or in the condition. If you recall, we actually tried one approach where we use the concept of set. We use union to do it, remember? We take out the sailors who have reserved green votes, and we also take the sailors who have reserved red votes, and we just directly do a union between those two sets. So actually, in MySQL, we can do that as well. So if we want to quickly change this by using the concept of union, okay, what do you think we will be doing? What we can actually do is, first of all, we keep here. Okay, So when it goes all the way here, it will select the sailor's name where the sailor have reserved a red vote. Okay? So if we take this whole thing in union with this, where we select when the vote is green, this will give the answer. Do you think it makes sense? Yeah, right? Because you can look at here thinking it's a set of the seller's name who have reserved a red vote. And here is a set of the seller's names who have reserved green votes. Okay. So we can actually do this. Okay, let's try it out. If I'm moving too fast, let me know. Okay, let me just... So it's the exact same answer. So the keyword here is unique. But if you recall, here is actually a not so good approach because it might cause some potential problems. If you look at here, we are taking union between two sets that are the S name, the sailor's name, instead of the sailor's ID. As not the primary key. Okay, so we can do this is just because it happens in the example that will not cause the problem of sailors having the same name, but they are actually reserving different kind of votes. So here, just for the purpose of practicing, we will use S. But if you think of it, really we should take the union between SIDs. If you really want the name of the sailors, you can take the SIDs here first. Then we can omit the sailors tables right here, right? Because we can get SID from reserves. Then the whole thing, later I'll show you how to join that with the sailors table. Back to the sailors table, then we can get this. Okay. So later we'll learn that's actually the concept of nested query. Okay. Any question for this so far? So now, if you take a look at query 6, okay, so we just did two approaches for query 5. If you take a look at query 6, and let's think about doing it from, so you have slide number 5 and 6, they're both for query 6. Let's think about doing it in a set, the idea of using set. Okay, so for query 6, we want to find the names of sellers who have reserved a red and a green vote instead of red or a green vote. So, when thinking of it in the idea of set, remember in relational algebra, we can just directly change here to intersect. So intersection instead. Okay? Okay, so that means we are taking an intersection between the set of sailors who have reserved a red vote and a set of sailors who have reserved a green vote. However, as I said in the beginning of the lecture, actually for our MySQL that we are using, it's not supporting the intersect. So we will need to use other alternatives. Okay? So here it can get a little bit complicated. If you're writing on the paper, just give some space between lines. We'll be changing around. So, here what we will do, instead of using intersect, because it's not supported in MySQL, we will use some other alternatives to do it. So before we start, you can actually think of each of these steps whenever we do a select from where, or just select from. It gives you an intermediate table, right? It's an intermediate result. So actually you can embed an intermediate result to another outer query to do a comparison. Okay, so for this we will call it a nested query. I'll show you what it means. So right here, the first thing we can do is, for example, we put a parenthesis around it. And also put parentheses around here. just to make it a bit clearer. Okay. So, right here we have this first table that gives you the S name of sellers who have reserved red vote. So let's just temporarily store it into a table. So if you do us something, then the whole thing will be called T1. Okay, you can name it whatever, like TMP or anything. Okay. And we want to say, I actually want to, so we go back up to do an outer query. You actually want to select the S name in T1 from the whole thing. Okay? So far if you only look at here, I'm just saying I want to select the S name from T1. T1 is here, the whole thing, in parentheses, right? From the parentheses. Okay, and we keep going. So you can actually say where the T1's S name is actually in here. Does it make sense? So here I haven't done any indentation, so it might be a little bit messy. So let me just repeat again. So if you look at this, we have a most outer query here. We are selecting the S name from T1. But what is T1? So here we actually say the whole thing. When we do this intermediate result, we store it as T1. Okay. But what kind of S name from T1 do we want? So we specify where the S name in T1 is also in the S name of this second intermediate result. Okay. So where does the idea of using set come from? So exactly right here. Okay. In is one of the set operators. So just remember here, intermediate result is a table. Here, intermediate result is a table as well. So just to make it a bit clearer, I'll add one more parentheses here. Any question for this one? Or it's pretty clear? We can try it and see what we'll get. Okay, so that's the answer. All right, so this is a rather complicated version for solving this problem. So there's another way we can actually think of it. Okay, I'll give you a bit more time to write that down. So let's say today we know, because MySQL does not provide intersection, and you want to avoid using intersection, but you still want to solve this, where we want to find the names of sellers who have reserved a red and a green vote. So what we can do actually is just to include same table for multiple copies. By that I mean, I'll go back here. I'll leave it up here, okay, and write it down. So by that I mean, again, we only want the S name, correct? So here it's all the same. And here we'll have some changes. So for sure we will need to save this because that's for instance. But here instead of just directly including one copy of reserved and one copy of votes, here we'll do 2 copies of each, and I'll show you why we want to do that. So we can do Is it too small? So right now, just before I explain why we need 2 copies, just remember we can't just directly say I want the reserves as R and want a second copy to do the same reserves as R. Instead, we should name them differently. Okay? So you can say the first copy is R1, second copy is R2, and both the first copy is B2, B1, and the second copy is B2. Okay. And why do we want 2 copies? Because here the idea is this. When we have 2 copies, you can actually have, let's say, R1 and B1 taking care of the record where red votes are being reserved. And R2 and B2 can take care of the green votes getting reserved. So how would we proceed? So we can actually say where, same thing, we want to associate the SID with the reserves first, okay? So we just do this first. Okay. And we also want to associate SID with the R2. Okay, so far it's easy. And what else? We also need to associate, now we say the R1's BID equal to the B1 BID. And also the R2 BID equal to the B2 BID. Okay, so far we're just trying to associate the tables together. But remember I said the reason we need 2 copies of each, 2 copies of reserved and 2 copies of votes is because we want one set of them to take care of the green votes, one set of them to take care of the red votes. So now let's say we want set number one to take care of the red votes. Then we can just basically say, and the B color is red, okay, and the B1 color is red, and B2 color is green. So can you see why this is happening here? And why would this work? Do you think it makes sense? Makes sense, right? Because for here, we're basically just saying for R1 and B1, we want those where the sailors only reserves the red votes. Then you could turn around and say for R2 and B2, I want the sailors who have only reserved green votes. Okay. But here, because we do this, where SID from S actually associate with both the reserves, so the final result will only give you the sailors who have reserved each color in different sense. This is rather confusing, but maybe you would think it's easier than this. Okay, so it's just another alternative. So we can take a look at what it should be. Problem. Yeah, we might have made some mistakes before. Anyway, I'll fix it. So for now, just think of it. This is correct, okay? I think the previous one is a bit off. Yeah?
So which way is better?
I think the first one is easier for me to think through. So we haven't talked about that efficiency or optimizing yet. So it just depends on you. And the second one looks cleaner. So yeah, depends on you. Whichever you think works better. Okay. So that is for query 5 and 6, which we like to do comparison, also in relation of. Okay. So a little thing to note before we move on is here you would think it's really messy. You might want to do some indentation. Right. So just be careful. I think for the MySQL we use, it doesn't support when you want to do indentation with tabs when you do select. I think for creating table you can do that, but for select it doesn't support tabs. It will give you error. So if you want, you can use spaces and just do whatever you want. Okay. So it doesn't matter how many spaces you do. If you think that will help indentation, you can do that, but just no tabs. Just one quick note for that. Okay, Let's move on and take a look at query 19, where we want to find the SIDs of all sellers who have reserved red vote but not green votes. What do you think we should do? Let's ignore this part. I think we won't reuse it again. So. Everyone got this? Delete it. So, let's take a look here. Do you think for query 19, we can change it up from here? So here we're saying something that's in another set as well. For query 19, it's basically saying something it's here, but not in here. Correct? So we can actually follow this kind of format of solving query 19. If we say, here I also still taking care of the reds, right? Red votes that are being reserved. And here also taking care of the green. All I need to do is just saying in red but not in green, which is like the set difference we learned in relational algebra. So all you need to do is just put a not. I think it makes sense. We still need to fix it a bit more because here it's asking for the SID. For here, if you think of it, here we have the sailors' names who have reserved red votes. And here we have sailors' names who have reserved green votes. So if we do where not in, it's basically saying for this set, we take a set difference with this set. Okay? So it's in here, but not in here. Okay? Reserved red votes, but not reserved green votes. That's easy. Right? So here, because it wants the SIDs, what it only wants is SID, do you think we need the sailors table? No, because it's in reserve, so we can take it out, make it cleaner. And because we don't need the S table, here, take it out. Here now we want the SID, which directly comes from reserves. So we just do this. Okay. And now, instead of S name, we want S. So that will be the final result. So let's look at it again. Then you'll see for this, the T1 part. Okay, T1 is from here to here. So it's just basically saying we want to select the SIDs where the sailors have reserved their red votes. Okay, and we need the votes information because it has the color information. Okay, and here's for joining the tables together. And we just basically repeat the exact same thing right here. Okay, and for the green votes. And for doing this, I didn't say earlier, so for us something, you're basically giving an alias. And because the reason we need it right here is because we're specifying from where we're selecting the information. And here we're saying from where we're comparing it. But we don't need it right here, okay? Because we're not doing a comparison, right? Selection from. Okay, so for the second part, we don't have to say as T2, okay? It doesn't matter. So that's for that. Any question for query 19? So it's very intuitive to directly change it up from the previous query. So far we have done quite a lot in terms of compensating the fact that we don't have intersect in MySQL, but we have union. Okay? So for query 20, where we want to find all the SIDs of sellers who have a rating of 10 or reserved both 1 or 4, we can actually really simply use a union. to achieve that. Okay? So, what do you think if we want to use union to solve query 20? What would you do? I'll just quickly type down. And we take a union with another select from where? Okay, so your task right now is to finish here and here. Think about it. What would you put for this first set of select from where and the second set of select from where if we want to do query 20? Let's say for the upper one, we want to get just the SIDs of sellers who has a rating of 10. Then what would you do? What are the tables involved if we want to do that? Anyone? If we want to get the sailors who have rating equal to 10. Only the sailors table, right? So sailors S. And we want the sailors SID, so we select S.SID, where the rating equals 10. Okay, so this is the first part. How about the second part? We want the SIDs of sailors who have reserved both 1 or 4. So what do you think will be the tables that are involved? Just the reserves, right? Because we only want the SIDs. And for the reserved information, it comes in reserves table. Okay? So we also want the SID. That's why we can take union. If you take a look at here and recall when we were learning relational algebra, to do a union, both sets, or both the inputs, have to be union compatible. Remember? And for union compatible, we're saying the schema is the same. And here the schema is determined by the select what. Okay. So here for the second part, we want to select the SID from reserve table, where what? We want to reserve both 1 or 4. So RBID equals to 1. That's it. So if we go back to take a look at this, the reason we can use unions because MySQL, it supports union, and you can take union between 2 sets. And here we're saying a rating of 10 or reserved 1 or 4, and that can map to the concept of union. Okay? But today we change it to rating of 10 and reserved both 1 or 4. We can't directly change this to intersect, but we can just follow the steps we have learned before, doing the where in. We're not in. Okay. Just remember, in MySQL we can't use intersect. So I'll just quickly show you what this looks like. Okay, so that's the inside. All right. So let's take a look at this slide. So far we actually have seen some queries that we did it in the way that is nested. Okay? So we have an intermediate result embedded into an outer query. So this is what we call nested query. So it's a really powerful feature of SQL that we can use. So early, let me see. So far we have put it in the where clause and the from clause. Okay, so later in the lectures, not today, but maybe next time, I'll also talk about we have a having clause we can add. Okay, so all these we can embed a subquery, which is like a sub-intermediate tables in there. So we make it nested. However, you can't put it in the select because it doesn't make sense. Select is also only selecting the columns one. Okay. So nested queries can be in where, from, or in having, which we will talk about next time. So just for the sake of clarification, the terms we will be using will be like inner queries and outer queries. Okay. So let's go back to query 1 that we have talked about a few times already. Anyone still need these? So for query 1, you can go back to select 10. For query 1, we want to find the names of sellers who have reserved boat 103. And last time we already used a very simple approach where we just basically select the name from sailors and reserves, right? And then directly say where the boat 103 is reserved. However, this time, if we want to change it into using nested queries, what do you think we can do? So if you recall how we would do it in relational algebra, so in relational algebra, if we want to find the names of sellers who have reserved boat 103, one of the not so smart ways is to take the cross product first. Even though later we learned about natural. For now, if we say, let's just directly take a cross product of it, and we take a selection where the SSID is equal to the RSSID, and the boat being reserved has ID 103. Remember that, right? This is what we would do in relational algebra. And eventually, we get the names from sailors. So if you so this can directly map to the query that we taught last time. I'll just quickly write this down, but oh no, that would be really long. But anyway, that's a right part of it. So we were doing select and the SS name from, sailors as reserves are, where we have these two actually. Okay, that's what we did. We just say SSID equal to RSID. Because it's in SQL, instead of using that, we say and. Yeah, my writing's really terrifying today. And RBID equal 103, because it's in SQL, you need to send it on. So today, if we change it up into a way that we think might be more efficient, because remember when we're talking about relational algebra, we say we will actually want to make the intermediate result a bit smaller, so you don't produce something massive then in the process of it. So one of the ways we can reduce the intermediate result, but it's smaller, is actually before connecting it or associating it with the sailors table, we just take out the reserved information where the boat is 103 first. Remember? So instead of doing that, we just say we just directly select the RBID. So here we only need BID. BID equal 103 first, okay? Because that's the only thing we care about. We don't care about both the other IDs. So we can take this out first, and then do a projection because we only want the BID. Oh no, we want the SID. Sorry. We want the SID. Correct? Then, for the whole thing, we can stick to cross product even though we like join more. But then, we take the cross product with the sailors. Okay? When we go back here, and say we want where the RSID equal to the SSID. Okay, and then finally, for the whole thing, we take S out of it. So then for this part you can see we already reduced the size of it a lot because we throw away, we discard information about this. Okay, so if we want to change this, or maybe we want to base on this to write the query, what would you do? So this is where the nested can come in. So we follow that idea. So let's try out what we will do for doing a nested way. Okay. So here, what do you think the inner query will be if we want to make it into outer part and inner part? I'll leave some space up there. Inner part is the thing we want to do first. Okay. So that will be just taking the reserved information where the ID is 1 and 3. So what you can do is just to do select r.sid from reserved where the BID is equal to 103. Okay, so that's for the inner part. Okay, and you can directly map it to the relational algebra we were doing before. Okay. Then you're basically saying, for the outer part, I want to handle the seller information. Okay, so you can say select SNE from sellers where the SID is in here. Okay. Can you see why this is mapping back? So, yeah, I just realized it's not that completely the same because right there we should do a comparison between the same SID. But here we're directly using the concept of sets. Okay? So it's basically saying for here I'll take out intermediate set first, okay, which is the SID that will satisfy this criteria. Okay? That the corresponding DID is 1 and 3. Then from the outer part, I take the SID as well, so that's a bigger set because that's all of the SIDs of the sellers. And just say, I only want those that are in here. Okay? So we have 2 minutes left, even though I only went through half of what I planned for today. Let's talk about the food. So, okay, I'll write it here. Anyone here is vegetarian? Yay. So that's a lot easier. Okay. So I'm not really familiar with a lot of pizza places. I only know a few. So I know Cove, I know Canyon. Please don't order Fasciolina. Can't afford it. Where else? Domino's, pizza. All right. So, anyone doesn't like pizza? I prefer chicken wings. Okay, I'll get some chicken wings too. So we have Coke, Canyon, Pizza Hut, and Domino's. Okay, I don't think we have time to decide the flavors. I'll take care of that. But we can vote for now from out of these 4. Any more that you know that's not on the list? College pizza. Papa John's. Oh, I forgot it.
This is college pizza. It's not.
Oh, it's awesome. Okay, yeah. All right. Okay, so before we should go, but I also want to ask you guys how many slices can you guys eat? I can only eat like 2 and I'm like super full. But I'm not sure the average. Like if we order like a medium size. Okay, I'll decide that as well. It means there won't be a lot of Coke. Who wants Coke? Canyon? We got 1 vote. Pizza Hut? We got 3 votes. Domino's? 7. We got 7 votes. College Pizza? 2 votes, alright. Papa John's? 1, 2, 3. Okay, 3 votes. So we'll get Domino's. Okay, so yeah, if you have any flavors you want, send me an email. Okay, before tomorrow afternoon.